We're gonna get going. Any luck? Today is, I think, the fourth or fifth episode, if you want to call it that. I'm working on a iPad note-taking app. Put all of the code that we started on last time up in this repository here, Draw UI repository. Another one, the page collection view. So this repository here is kind of what the note-taking app will eventually look like in terms of how pages are organized. You can see you get a list of kind of notebooks, for lack of a word. Then you get a grid view, and then you get a scrollable page view. And then each of those pages will be drawable using probably one of the views we make in the Draw UI. When I made Loose Leaf, which is this application here, so it's an iPad app. You can draw, cut, scissors, move the scraps around, draw on those scraps of paper. You can import images or the camera of my floor. But when I made that app a bunch of years ago, I explored a lot of different ways to render the screen, and what I settled on was an OpenGL implementation that I'm moderately happy with. The benefit that I had was that there was alpha, there was opacity in the stroke, and so I could have a semi-opaque stroke, which was nice. So the pen didn't have to be black; it could be a semi-black or something like that, and it was fast. I could render really, really quickly, and so the latency from the pen stroke to the tip of the pen was really short. Whereas if you draw in, say, Core Graphics, as you move the pen stroke, your actual stylus might be here, and the rendering might be right here, and then it needs to kind of catch up slowly. That last little bit, it's just a little bit out of sync, and so OpenGL let me have a really, really short distance in between what was being drawn and where the stylus was, and so that was a big benefit. The downside is that I don't know OpenGL terribly well, so it was very difficult to build. It's been very difficult to maintain. It's been very difficult to improve. I think in iOS 11 or 12, OpenGL was deprecated, and so everything's moving over to Metal. And so then to migrate that is going to be very, very difficult and probably out of my depth. And so, but I learned a bunch, and I had tried rendering a bunch of different ways. I probably wrote 4 or 5 different renderers during the course of building this app, and all of the code for those, though, is lost, and they, as happens, you write something and then delete it, and then you write a different thing and you delete that, and you write a different thing and delete that. So all those things are gone, which brings me to this Draw UI. My goal with this eventually framework or library or whatever we want to call it, I would like to collect all of those different rendering methods inside of here. And so we can see what we started last time. We can render using CA layers. We can render using, where is it? Here's a draw rect, and then there's another draw rect implementation here. So there's already there's already 3 different renderers that we can use. And what I would like to do today is build a 4th, and that would be to use CA tiled layer, which is what the zooming PDF sample code from Apple uses to render high resolution vector PDF data to the screen. And so I thought that would be interesting. And then the other thing that I would like to do Right now, all of our renderers have, if you draw a stroke like this, it's going to be a single width. But you can see here, when I draw slow, it's really thick. When I draw faster, it's really thin. Not sure. Yeah, this one is just pretty much always thin. This one has a bit more texture to it. But what I would like to do is be able to support that style, because our current style just has a fixed thickness in the width, and I'd like to be able to have a variable thickness of the width. We might start playing with that today as well, but we'll see. We'll see where things go. But for now, I would like to up what we have. You can see it's configured here, and so we can just create. Here's our 3 renderers. We can just pick one of the renderers. This one happens to have an option on it, and then we can install it, and then now we can use it. Once the simulator finishes launching. There we go. Now we can draw, but you can see that everything is just a single thickness, which is fine. It's nice, but eventually I'd like to be able to get a variable thickness there, and then to support the pencil's pressure inputs and that sort of thing. But for now, let's come up here. We have a CA layer renderer. Let's do a new rendering option. Do I think this, we want to mirror this one. This one's object. Yeah. So, oops, I can't. Do a CA tiled layer renderer. And then I'm going to open up that PDF renderer so we can see how that actually works. I just create a CA tiled layer. Those look like reasonable defaults to me. Sure. That was just some debug code I had for that implementation. Great. All right, let's give it a go. So let's just take our CA layer renderer. Go. And when we initialize, we can have our tiled layer here. We'll build it right here. Let's implement that delegate. Not just a layer delegate, is it? Is that all it was? Yeah, okay, fair enough. All right, so if our tiled layer, we don't have a super layer, then we will add it. Right? We can do that here. And we don't need to render here. Okay. And we implement the CA layer delegate. We're going to want that one right there. We want anything else? I don't think so. Right? Okay, so we're going to keep also track of our last known model. That helper's going to be gone. Context. Right? That feels okay. All right, so here's my thought. Model. All right, so here's my thought. We have tiled layer. We're adding that tiled layer to the view when we're asked to render. Great. I don't even need this section. Let's just take that out. So whenever the model updates, we make sure that we're added to the view. We save the model, and then this should get called. I think I might need to that needs display, and we might do the same thing we did here in our smart draw rect that we did last time, where the portion of the stroke that the user is actually drawing currently, the only part of the view that we actually need to re-render. And so we're going to take just that portion that they're actively drawing, compensate for our stroke width, which we can actually put into constants file. Yeah. Compensate for that width. and then only render the portion that we actually need to, which I think would be really good. File here. Now everything should compile, which is good. And now we actually turn that renderer on and find out why it does or does not work. Import it. And see what happens. What should happen, I hope, is that it will initialize correctly. We'll set our delegate. What might be wrong is that this guy's his size, the bounds, I never set that, which is probably bad. I probably need to set that there, but I'm not going to, just to see what happens. And then as we draw, I think this will happen, and then this should be called on a background thread per tile, as I recall. Let's find out. I'm gonna drink some. Okay. Something's happening, presumably. Yep. So we have a tile layer. Great. I think you 0. Yep. What if we do that? Actually give it a size that feels very reasonable. There we go. Great. Invalid context. Set that as the current context. No. All right. Well, what if we do this? What if we do CG context color, set stroke color, we want color with color, black color, CG color. Here we go. And then context path. Add path is probably what we want. There, let's try that. So that creates our path, sets it to black, adds it. Probably need to do that. Fine. Cap. I don't care. We're just gonna leave those as defaults. Doesn't matter. Doesn't matter. Simple, simple. There we go. So now we're using the fun. Did not expect that to just kind of happen. Now we're using tiled layer to render. Pretty great. So how can we, I want this guy, current context. Can't I set the context somehow? Like set a current context? Set current context ref. Anybody knows, tell me. UI graphics, get current context. They're not a UI graphics current. Push context. There we go. That's what I want. Yes. And UI graphics pop. There we go. And so now we don't need that business to broke. There. So now that's just a little bit easier to read. It's the exact same thing happening, but yeah. Easier to use. Great. Cool. That was really quick. Right. So the code today is available. Oh, right. Fetch. I added a license file. Here we go. So the code today is available at Git URL. Welcome to download it and play along as well. Now we have a bunch of different renderers I'm excited about. Oh, come on. I was excited about it. So I made a silly mistake. Here we go. Now all of our files are actually in Git. Fantastic. Okay, so we have a bunch of different renderers. I would like to go back to just a naive draw rect. This guy, he's just going to draw on a canvas. I feel like this is the simplest out of all of them. But what I want to do now is work on dynamic width for the stroke. And I have a pen tool. Where do I ever create that pen tool? Create it in here, maybe? Model. Okay. Pen size 2. So let's make it like from 4 to 20. So that way our pen has a lot of variability based on the velocity. Could use velocity. Okay, it's just always going to use velocity. Great, 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 great. Yeah, okay, awesome. Okay, cool. And so then in our naive, we get this. let's add a toggle here for using dynamic width, right? So this is for not dynamic width, and now we want to have a draw option with dynamic width. And actually, I'm going to take this guy. I want to add him as part of the protocol. Yeah, and then I want to add it to everybody for everyone to use. Go. No build warnings. Feeling pretty good. Great. Okay, so now the math happens. Not the worst math in the world, but the way that things are set up is it uses a segment smoother. And so what the segment smoother does is as I'm drawing a line, what's actually coming in is a touch point, a touch point, a touch point, a touch point. And so very naively, I could just connect those with a straight line, and I would get a very gross looking, be fixed width, it'd be sharp corners, the whole thing. It wouldn't be very smooth or natural handwriting looking at all. So instead, what I did, that segment smoother takes all those points in and creates Bezier path segments for each section in between points, right? And so that segment has a start point and an end point, and it has a control points here, and it has the actual path of the stroke. And so there's the control point. Those are tangent to the stroke there from the control points. So that's what helps define that nice smooth curve. And then you can kind of patch those curves together, get the entire stroke. Well, this piece, this single piece, is one of these curve to path elements. And so this element is what kind of contains all of that curve information. But it also, I have it extending this kind of abstract element that gives us a width. It tells us the start and end, but most importantly, it gives us that width. And that width is at the beginning of that. No, it's at the end of that stroke. By the time that segment ends, so I have that is, that first dot is this move to path element, which extends the abstract, and so that move to path element has a width, so that's our starting width. And then after that starting point, we have one curve with an end point here, so that has width 2. This is width 1. So then we have a different width right here, and yet a different width right here. So I'd like to be able to interpolate the thickness of this line along the line, so that way it arrives at width 2 at this point, It starts at width 1, and it's in between the widths in the middle, right? And it's even closer to width 2 over here. To do that, my plan is to have at each point a circle, and then at the second point a larger circle. So if here's our point, and here's this point, and if here is our curved line, then at this control point, that gives us a line that is tangent at that point. Okay? And so then perpendicular to that, I go out on the radius of the circle. I find 2 new points. I give those new points control points. I do the same thing over here on the start point from its control points. And now I can attach these with the same style Bezier path that was here. Now this gets a path, this gets a path, and then they're completed with the last half of the circle right there. And so what ends up happening is from this point and this point of the drawing path, and from the definition of their control points, we can calculate kind of a bounding stroke path the whole way. And then this would be connected to, so if that's one of them, right there, that's actually going to be connected to the next stroke on the other half of the circle there, and then the next one is going to be connected there, and the next one is going to be connected there, right? And so this is a circle, this is a circle, this is a circle, this is a circle. And by the nature of the smoothing algorithm, this point and its control points this way are parallel. So there's a tangent right there for the stroke line along its connecting circle. Hopefully that makes sense. That's the goal. So then what we need to do is we need to calculate these points and then calculate these semicircles, and then we should be able to just calculate everything else magically and create that that border for each stroke piece, right? Okay, so here, this has a path element where it's concatenating all of those segments. What I would like to do here is add a let's call it a border path. Make it a property. Yep. Our default implementation is going to for an exception. Fine. All right, our move to path element, probably the easiest out of all of them. Because it's just going to get a circle inside of a rectangle. This go self start point dot x. Oh, we actually just want basically that. Yeah, we want, actually we want exactly that. What am I doing? Yeah, we just want the self-bounce. Great. Yeah, that's obvious and easy. Okay, so that's just going to make a circle at our start point, which is great. And what I want to do for now is curve. I want to do a very similar thing. I just want to visualize what it is that we're connecting together. Okay. So there's an endpoint, and I also want to do a path. Don't I have a no, I don't. That's fine. That move to point, self start point, add curve to our end point, our control points, and there is a method path stroke path. What was it? We used it. Yeah, here it is. That's what I wanted. That's the. I always forget what it's called. Great. So what this is doing, this path by copying a stroked path. So what that's doing is when you draw a path like this with a width of say 10, then iOS is actually kind of creating a thickness, so that way your thickness is 10, and it's filling all this in, right? Your actual path is this center line, and so what it's doing, what this method is doing here, is create copy by stroking path, is it's actually giving us this outline as a new path, right? So it is directioned filled thing, and so then instead of asking it to stroke this path by 10, we tell it to fill the path it gives us by 10. And what that lets us do, we can append the endpoint path, return stroke. So what we've done is we have a circle at the end of each line, and then we have the actual line we're drawing around. Turn it. Border path, isn't it? Is it border path or bordered path? Border path, that's fine, that's fine, that's fine. Okay, so now we go to our renderer. on stroke. What do we call those? Oh, do I not? Segments. Huh. Okay. Those should be public. There we go. All right, so now here we can look at our segments. On that border path. Yep, fine. There we go. So we're going to fill it with black, and then for each segment, we just fill it. And then we do the same thing for the one that's currently in process. Model stroke segments. Okay. So what I'm hoping to see when we draw now is I'm hoping to see something that looks like circle, bigger circle with a literal line going through it. So I'm hoping to see something kind of like that. And we don't see any of that. See any of that. There we go. Let's turn that feature on. That'll help. That makes me really skeptical. Really, really skeptical. Why would it be doing that? So let's look here. So this, this border path for the curved path element. Set line width 1. Oh, our K stroke width is still 10, so that's why. That to be 1. We can make that 2. That's fine. All right. Let's try that. Yeah, so now it should have a width. Yeah, now I think we're in business. But maybe all of their widths are set to 0. Yeah, you're a width of 0. Okay. That would be why, is we're not setting the width anywhere. Now here's where we're building it. View. So we have a touch velocity, so this is where we get our velocity. I think the only problem is that I did not install that. So then every velocity is 0. There we go. See if that gives us any width or not. Go. Initialize with the pen. Good. And we don't actually use the pen anywhere. Is that what's going on? All right, cool. So now we can get the pen size here. Let me look and see how I did. Yeah, we want width for coalesced. All right, what if we do it this way? I don't know if I want the pen there, actually. I don't think that's the right place for it. And instead, we're going to take the we're going to return the element whenever we add it. And then the caller can yeah, and add any width information that they want to. So that'll happen in the draw model. Have abstract element here. Then here is where we would deal with velocity. And so the draw view tool, yeah, but it has I want to open up loose leaf and see how I did this over there. Because the touch moved. Okay. Yeah, that's fine. Yeah, so all I did here was these methods should be exposed publicly. Yeah, because those are left over from being the job view delegate. Yeah, okay. Let's move these publicly for now. I don't care about this will add elements business. Yeah, because you don't do anything. We have will begin, we have will end, we have will move, we have a width, and we have a smoothness. So then in our draw model, have oh, it's from the event. So then we even want to enumerate over those. Yeah. Right? Yeah, we do that in moved. Okay. I don't do it here. Makes sense. Oh, I already do it here. Okay. I was already doing the right thing. I'm just confusing myself. It can get the iPad can get a lot more touch inputs than it can send at one given time. So this method might be called once every like 30 times a second, but it might get 100 touch inputs a second. And so this coalesced lets it send multiple touches per touch in the view, which is my understanding. In dot view, because that doesn't make sense anymore. This is just a raw view. housekeeping, renaming things. Okay, so now we have a width. Now we can get a smoothness. Smoothness variable here. Go away. Yeah, that's fine. I'm not sure that I like passing billion things here. Part of me wants to just take this method out and just have an append element method on the stroke. Probably going to be better. But the nice thing here is that you can have a smoother per stroke, so you could potentially have multiple people drawing with different strokes at a time. You wouldn't have to keep track of that. So anyway, I'm clearly overthinking it. The moral of the story. Oh, it's read only. So when should I add the width to it? Still do it in here. There's another good reason to not be separating these things out. Okay. So then we take our smoothness again. Set our width to go. Do the same down here. Short stroke ending. I don't know what that is for. I don't remember that. How do I calculate that? Is that just if the entire distance of the path is short? Oh. All right. That way, if the user just kind of taps on the screen, they get a they at least get a dot. Okay, so I think that's a reasonable place. So that was a lot of kind of back and forth and ridiculousness, and I don't like that this is just kind of hanging out. So we're going to do one last thing. We're going to take the smoothness width. We're going to make it look like that. Set the width here. That makes me feel better. That's certainly a cleaner thing. Mine ended up changing anyway, but that's much better than the business we had before. Just one. All right, so now I think we're actually ready to test it again. And again, what I'm hoping to have is dots that are the size of the width with a line kind of connecting them of where they're going to go. And then once we get at least that far, then we'll work on actually filling in the gaps here. That way, all of it looks like a really nice and smooth, line. Let's see if we can at least get that far. Hey, there we go. It's nice. By nice, I mean it doesn't look pretty, but it works pretty great. So now we need to connect those and smooth them out. I wonder what that's actually going to feel like to draw with it, because it seems like it gets enormous really fast. It probably does, but that's fine. We'll get to play with it and then make it feel better. Okay, so let's in progress for fill dynamic width strokes. Right. Cool. Now the only thing we should have to fix is, or to finish, this guy right here. This guy, we create the dot at the end of it. Do we know? We don't know what our previous element is, I don't think. So our previous width, I think we want to validate. Is that how we get it? Yeah. So Here we go. We have our width. We validate given the previous width. That's going to set. That's going to give us all our information about what came before. Yeah, cool. So then now we should have all the information we need because we have our oval. We have our width. We have our previous width, and so now we should be able to calculate our extra points. And again, to do that, have our start point, our end point here, have our control point, That's going to give us a vector, and then we can look at the normal from that vector to get a point out here. Let's just get those points. And should have everything we need. I have a convenient vector class, so we can do start vector, our start point, and our control point. We want a perpendicular, and we want it normalized to our previous width. We just want it normal 1. That returns it, right? I think these are all immutable. Yeah, great. So point from point, self start point, and a distance of self previous width. Left start, right start. Cool. And so then we want to do the exact same thing from the end. So our end vector from our endpoint to control 2. Perpendicular normal. And then we're going to have our left end and our right end of our width. Right? That feels good. And now I think what we're going to do, now that we have those 4 points, so we have the points that we have theoretically, or we have this point, we have this point, we have this point, we have this point. And one of these is the left and one is the right start. One of these is the left end and the right end point. And so we can connect these just with a square and see what happens. If we at least can figure out what order they're in. Let's do that here. So we'll move to left start, add line to, left or right start. Close path there. Let's try that. So what that's doing is that's building that kind of quadrangle around those 4 points that we got. Yeah, that's fine. And circle, and then this is going to be calculate the curved border path, right? So I'm just going to draw one stroke really fast to hopefully get yeah, so it did not we have a vector. We have points 128, 636, 128, 636. Oh. Point. Endpoint. There we go. Yeah, so it was drawing them, but it was drawing a rectangle filled right here with a zero width rectangle. So that's not helpful. Now that we have some from the starting point and some from the ending point, we should get something, but we still don't get anything. So why don't we get anything? Left start, right start. Oh, negative width, negative width. It was the exact same thing, exact same problem. There we go. Now, if that doesn't look good, I don't know what does. But you'll notice that it crosses, and so that means we have something out of order. So if we go negative, negative, then I think we'll get a yeah, there we go. Why are my widths always the same distance apart? Four seems reasonable. 4. Always 4. Why would it always be 4? 4, 15, 4, 4, 4, 4. Lots of 4s. Some 11s. I'm going to try drawing it without the without that last circle. There we go. So it is changing the width, it's just the circle's kind of eating everything. Alright, well that's better news than I thought it was. Pretty good. Now instead of using lines, I'd like to calculate the control points to smooth that out. I just thought of one potential problem that I don't think is a huge deal, but it's a little bit of a huge deal. So the potential problem that I'm thinking of is we have a small width here. The next element is much bigger. Then right now I'm calculating our control points are there. So it's a straight line. It means this would have a control point, straight line, and this would have a control point being a straight line. I guess that's okay. So my thought was that this tangent is different than the ruler. Right? So that one, this tangent hints slightly forward on that circle compared to a horizontal tangent, which is going to be slightly behind. This kind of rolls forward, and so since I'm using this point right here, I'm not using this point. But I think that's okay. I think it's going to be a non-issue. I'm not going to worry about it for now. We're just going to see how it looks. Okay, so from our left start, I'm going to have some control points. And we have our start vector, point from point. Magnitude. Mag and start mag. We'll call them distances. Okay. Our start distance, point from point, and our control 2 is going to be from our, it goes from left start to right start of end distance, right? Then we have stroke, add curve to our end, to our right start, control 1, control 2, and now we're just going to watch that happen. Because these control points, they should be pointing this way and this way, but I'm not really entirely sure which direction this points us, and so I might have accidentally pointed this way and this way, which would be hilarious. Let's find out. I think it's actually okay. Maybe? I think it's okay. So then we go to right end, then we do the same thing here, except we're coming from right end, and we're going to right start. Okay. The left start to right start. Oh no, gosh, I did this way wrong. Doing it backwards. I want it here. Left start, right start are on the same side. So then I want it from right start to right end. And then here, I want that. I want it from left end to left start. Yeah. That's what I want. And this is going to go from curve to point. We go from right start. I create a control point for the right start point, a start distance away. That's here. And then I create point from the right end, 4.2 end distance away. And I go directly to left end, and I create my next control point an end distance away. Yeah. Yeah. Good. Yeah. Very cool looking. Really fun. Okay. Point path. Calculate the circle. We don't care about that anymore. All right, cool. Okay, so if we have the draw model, what I want to do is I want to make this easier to test and easier to debug. To add point smoothness. Point. Now that's good. And we'll take that and go here. Yeah, I like that. Because now I can go into our view controller. We have our model right here. I'll just do it right here, and I'll just add a width of 5, 50, let's be 150, 150, 10, 15, be 100, 150. Let's just see what this makes. There. That should draw something. Maybe when I set the renderer, nothing is actually, yeah. If I do that, so it has some segments. Added a stroke. have an element, have a move to element. It's not gonna do anything. Curve to element. Curve to 150. 100, 100. Make sure I'm full size. Left start, right start look okay. I guess those look okay, right? Yeah, okay, there we go. It is drawing something. I don't know why I wasn't drawing something before. Maybe I just wasn't being patient. Okay, great. Now we have something to debug. So let's make this a lot longer. So it goes 250 x and then 150 in the y. Let's just make it one curve long. What does that guy look like? Maybe he doesn't look like anything. Maybe I need 4 points. I thought I only needed 3 input points. Yeah, I have 2 segments. I have curve, reasonable. So I start at 195. I go to 352.85. Right? Feels fine. I should have 2 curve 2s. Oh my gosh. I'm disappointed that it took me that long to find. That's amusing. Curve, line, curve, close. Great. That's much better. Good. Y. And this one is 352. 6. This one I think is wrong. Hey, there we go. Man, look at that. Looks like we did it on purpose. I want to draw the control points. So inside of inside of this border path, here's what we're going to do. Do I have any nice did you work from point size? Fine, let's do that. Correct. Point, left start, size make, self previous width, fill. There we go. Go back to our renderer. Just going to do this to help us out. Okay, so now my start and end points are going to be red. I'm going to make my control points green. I think that will help visualize what it is that's going on. Well, not really. And maybe not really because they're getting covered up by the black. A 2, let's make them 4, or let's even make them 6. Okay, so one set of points is right on top of itself. The other set of points is really low. I'm calculating the red points wrong. Definitely calculating the red points wrong. This should be, red points and green points should be basically making a rectangle, not a line. So if I do one, okay. So that's my path. That's where my path should go. These two green dots should be kind of in the middle, and these two green dots should be kind of in the middle. I'm calculating things very, very wrong. Up here, this start vector from start point to control 1, get my distance. Oh, my start vector, not make it perpendicular, maybe? Make it perpendicular there, because I think I'm confusing myself. Confident. This is going to be our offset vector. Oh, end vector. Yeah, so that was a bug. That was definitely a problem. It'll be end offset vector. Okay, so now my end vector should be correct. Start vector normal. This is our end vector. End vector. Yes, there were all kinds of problems in here. That's another one. There we go. Hey, there we go. That looks a lot better. So they're still not lined up quite right, because these red dots should be on the circumference of this black circle. And I suspect, let me draw the black circle here too. Here's my move to element. my border. Yeah, that's what I want. Well, that's what I want. We go, and we want to do that at the end point. Yeah, so you can see this red one, they're not quite on the circumference there either. I mean, they're close, but they're not, they're offset a little bit. Weird. I think I'm not rounding or anything. Get the perpendicular, I normalize it. Get a point from point. Oh, I think you know why. Yeah, that's why. It's because I'm doing that CG size 0. Yeah, okay. So it's actually, it's in the right spot. Six. There, that's what I want. That way it'll be around that, that point instead of origin at that point. Control 1, 2. We'll want to control 2. Okay. I think that's gonna fix the offset problem. Yeah, okay. Now they're all in the correct spot. You only need them to be man. Go. Copy. There. Okay. Okay, so now the red dots are on the side of the black dots. We had our control points correctly. So now we should be able to hey, there we go. That looks better. Okay. So get rid of that debug code. Get rid of this debug code. Curve. Naive renderer. Oh, actually, we do want to add that. Those dots, red dots. There we go. There we go. That's what we want. Now the other thing that we want to do is when setting the width, right now it's like ink blots, and so we want the width to grow a lot slower. Well, the other thing we want to do is we want to get it to not ridiculous values. If we go from like 4 to 8, what the default was. Now we're starting to get something that looks a little bit like a pen, like a little bit like a signature. It's still a little ink blotty. Let's put it back up to 20, and let's fix the ink blot aspect of it. So don't care about our demo anymore. Okay, I'm trying to figure out what the difference between this guy, which uses force, and this guy, which uses force. There might not be much of one. But anyway, it doesn't really matter. What we want to do is make this quite a bit more sane. One way to do that would be looking at our last width. So if our width minus last width is greater than, say, 1, then width equals last width plus 1, plus the negative 1, then width equals last width minus 1. That way, each dot is only going to be able to grow a little bit at a time. That's clearly not doing what we want it to do. Oh, and then of course we set width. Oops. There we go. I mean, that smooths it out a little bit. We could even do it more for then what if we do min size is 1 even. Let's do 2. Let's do 2. threshold, it can grow by 0.5 point. And we can decrease it by twice the threshold. That's really pretty good, right? That's not bad. Find that. Go slow, it's thick. Go fast, nice and thin. Cool. And the other thing we could do is actually maybe no. Fine. Invert size. This math equation should not be that hard. I don't know why I can't think straight on it. Yeah, that's right. And then our pen, invert. Oh. Here we go. Now instead of being, it should be thin. Oh, that's funny. Yeah, I'm thinking that wrong. It does invert it, but not the way that I want. Maybe that's what I want. Velocity. I don't know. Whatever. Be a problem for another day when my brain has more brain. But for now, I'd say that looks reasonably good. Get a nice kind of pen look to it. There's definitely a lot more we could do. And once it slows down a little bit, it gets ridiculous. I think the right way to do that, the right way to clean it up, would be to set that to say 6 or 7, and then what happened there? PG numerics, that's environment variable. That was weird. Huh. Well, next time we ever accidentally trigger that bug, we'll fix it. There we go. Oh, you know what it is? That happens when one of our distances in here is 0. Like this distance here might be 0. Potentially. Somewhere there's a nan inside of here, and that's the problem. That's definitely the problem. Yeah. Then if isnan or isnan yeah. We could just do a void checkpoint point that they're both not nan. We can write start right end, left start, left end, and then we can also check our control points. Control points 1 and 2, points 1 and 2. There we go. I think that should catch it now. There we go. Yeah, so our right endpoint is not a number. That's because, why would that be? Our end offset vector is not a number. Our end vector 0, 0 yeah, so our end vector is 0, 0. So I think perpendicular, define our normal length There we go. That should fix it. That way, if we have a length, great. Then we can normalize our vector, and if our vector is length 0, then we just return our length 0 vector. Feels pretty reasonable. Yeah. Cool. Cool. Yeah, that feels really good. Cool. Good deal. Dynamic width stroke. Cool. That feels pretty good. I think this is going to be a good place to call it. Here is the code that we've been working on today. That's the URL for all the code. Thanks for hanging out. I enjoyed it. I'm pretty happy with where we're at. What we did is we made a CA tiled layer renderer, and we also worked on creating a path that we can use to fill instead of just a single width path that we can stroke to draw it. Instead, we can fill the path and get a variable width, kind of dynamic width stroke, which gives us something that looks a bit more like a pen. And then what we can do probably next time is, right now we just implemented this in our naive renderer, and so we'll implement this also in our smart renderer and our tiled renderer and layered renderer and everything else, and get that going, and then try some other things. One other thing that I'd like to try is so right now when I draw a stroke and it's actually separated into a bunch of elements, and then say in the smart renderer we say, okay, only render that rectangle. Well, if this stroke intersects this rectangle, then I draw the entire stroke. And so another optimization we can make is we can draw only the segments of the stroke that actually intersect, so we can only draw just these pieces instead of drawing the entire thing. That might also be interesting to try. And then that way, as you're drawing, for instance, we're not drawing this and then this and then this and then this and this and this, and we end up drawing, what's that, like n log n times instead of just n times. And so that would be another optimization that we can make, if nothing else, for the stroke that's currently being drawn, even if we don't do that for all the strokes that have already been drawn. But anyway, so that would be interesting. But I'm happy with where it's at. I'm happy that multiple renderers work. I'm happy that we can calculate the filled path for a stroke. Let me move this back, this back. Yeah. Yeah. Okay, cool. Yeah, I like it. Thanks for hanging out. Enjoyed it. Have a good one. See you next time.